Grade 11, grade 12, I welcome you to today's lesson. Today we are going to look at redox reactions. You can see that there are two definitions that I've put there, the one for oxidation and reduction. Oxidation is the loss of electrons by a molecule, atom, or an ion, whereas reduction is the gain of electrons by a molecule, an atom, or an ion. We'll talk more about this in the next lesson. Today's focus is on oxidation number. Oxidation number is the charge an atom would have if it was in a compound composed of ions. There are rules that one must know about oxidation number. You will be asked to calculate or to determine the oxidation number. So these are the rules that must be followed. A molecule consisting of only one element always has an oxidation number of 0, since it is neutral, e.g. H2, Br2, and A. What is the meaning of this? I've used a red pen here to expand this example of just saying H2. A molecule consisting of only one element always has an oxidation number of 0. Meaning this: H2 equals to 0. That's the meaning of this statement here. H2 equals to 0. If I work out this to find H, the following must happen. Is 2H, you can write it in this form, 2H equals to 0. To get H, we divide by 2 and also divide by 2 here. Our H equals to 0. You can do the same with Br2. You can do the same with Na. With Na, you can see that is Na equals to 0, just like that. That's the meaning of this rule. Let's go to the next one. Ions with only one element or type of atom have an oxidation number that is equal to the charge on the ion. For example, the chlorine ion has -1 and Mg2 plus has +2. To expand on this example, chlorine ion equals to -1. If you are asked to write the oxidation number of chlorine ion is -1. Mg2 plus, the oxidation number is +2. Let's go to the next one. The sum of the oxidation numbers for each element in the molecule or compound will be 0. For example, H2O equals to 0. H2O equals to 0. So if I have to calculate the oxidation number of hydrogen, for example, I can make use of this provided that I know the oxidation number of oxygen. The next one, in a polyatomic ion, the sum of the oxidation numbers is equal to the charge, e.g. SO4 2 minus. If I have to, for example, work out the oxidation number of sulfur, I will write the following. SO4 equals to minus 2. That's the meaning of what I've just read here. In a polyatomic ion, the sum of the oxidation numbers is equal to the charge. That's why here I'm writing equals to minus 2. Let's move to the next one. Oxygen atom has an oxidation number of minus 2. Oxygen atom has an oxidation number of minus 2. Where there is oxygen, you put minus 2. But there is an exception. There is an exception. If oxygen is bonded with fluorine, or with peroxide, things are different. That oxygen will have an oxidation number of minus 1. Oxygen in water will have a minus 2, but oxygen in H2O2 will have minus 1. Let's look at the next rule. Hydrogen, there's a mistake when it comes to the spelling here, but hydrogen with non-metals will have plus 1. If hydrogen is bonded to a non-metal, its oxidation number will be plus 1. But if it is bonded with a metal, its oxidation number will be negative 1. You can see that I've given the example here. Hydrogen atom in water is plus 1, while hydrogen atom in lithium hydride is negative 1. The oxidation number of fluorine is negative 1. You come across fluorine, you must know that the oxidation number is negative 1. The oxidation number of alkali metal is plus 1. These are group 1 elements. And then sodium and potassium, their oxidation number is plus 1. You see potassium, you see sodium, you must know that the oxidation number is plus 1. Group 17, fluorine, chlorine, and Br, the oxidation number is negative 1. Now, we are going to use this information to answer the following questions. A few questions that I want us to answer. Find the oxidation number of the underlined element. Here we have H2S. And then we are required to find the oxidation number of S. What is it that we know? Remember, in one of the rules, I talked about hydrogen. If hydrogen is bonded. Let me bring the paper back. Hydrogen is bonded with non-metals. The oxidation number is +1. Then our sulfur is a non-metal. It means that the hydrogen there is +1, not -1. It's +1. So how do I move to the next step? This is what we do. H2S equals to 0. H2S equals to 0. The charge here is neutral, ne? The charge here is neutral. That's why I'm saying equals to 0. The next step is substitution. We know the oxidation number of hydrogen when it is bonded to a non-metal is 1. So 2, these 2, open bracket, 1 for the oxidation number of hydrogen plus S equals to 0. Then we solve for S. We'll take this 2 times 1 is 2, then we'll take it to the other side. When we take it to the other side, sulfur equals to -2. Sulfur equals to -2. Let's move to the next one. In this one, we are required to calculate or to find the oxidation number of Cr2. Do we know something about oxidation number of oxygen? Yes. That oxidation number is -2. And then, how do we start? This is how we start. Cr2O7 equals to -2. The charge that Cr2O7 is carrying -2. Then we put it on the other side of equal sign, as one of the rules says. Then the next step will be Cr2 plus, we know the oxidation number of oxygen, which is -2. -2 multiplied by 7. -2 multiplied by 7 equals to -2. Then next step, 2Cr. I've written it in this form. 2Cr -2 times 7 is -14 equals to -2. We take 14 to the other side. It will be 2Cr equals to 14 minus 2. 14 minus 2. Then next step, 2Cr equals to 14 minus 2 is 12. Then we divide by 2. The final answer will be Cr equals to plus 6. Cr equals to plus 6. This is the oxidation number of Cr. Let's move to the next one. KHCO3. And then we are looking for the oxidation number of C. Hydrogen is bonded with carbon, which is a non-metal. It means that our hydrogen here is 1. K, I've showed you something regarding K. Let me bring back this paper here. Let's look at this rule here. oxidation number of alkali metal is +1. Sodium and potassium is +1. So our case 1. But I'll first write it in this way before I do substitution. KHCO3 equals to 0 because of this 0 here. Charge 0 here. Then substitution. Our K is 1 plus. Our K is 1 plus. Our H is also 1 plus. C, the one that we are looking for, plus. Oxygen is -2 times 3. -2, the oxidation number of oxygen, times 3 equals to 0. Then we work out this. 1 plus 1 is 2, plus C minus 6 equals to 0. Equals to 0. Let me take this to this other side. Then we solve for C. We solve for C. C equals to 2 minus 6 is 4, or it's -4. Then you take it to the other side, it will become +4. It will become +4. That's our answer. Then, moving on, let's go to number 4. We are given Hg2, then 2 plus. What do we do here? Hg2 equals to +2. Next step, you can write this one in this form, 2Hg. 2Hg equals to 2. What will be the next step here? Let me rewrite this here. Next step is to solve for Hg. You divide by 2, you divide by 2. Hg equals to +1. Hg equals to +1. The next one, KMNO4. We'll write KMNO4 equals to 0. We know the oxidation number of K, and we know the oxidation number of oxygen. The one for K is 1 plus Mn, the one that we're looking for, plus oxidation number of oxygen is -2, then 4 equals to 0. 1 plus Mn minus 8. Minus 2 times 4 is -8 equals to 0. Final answer, Mn equals to 1 minus 8 is -7. You take it to the other side, it will become +7. Let us look at number 6. Before we look at number 6, I want to bring something here. So from the textbook, I want to bring something from the textbook. I hope this is visible. The issue of cations and anions. Cations and anions. Remember, here we're given MnSO4. MnSO4. And we are required to calculate Mn. We are required to calculate the oxidation number of Mn. We know the oxidation number of oxygen, but we don't know the one for this sulfur. If you come here, maybe this will be visible. sulfate. Let us look at sulfate, which is SO4 2 minus. Sulfate, if we make use of this, if we make use of this anion, we can calculate the oxidation number of S, because we know the one for oxygen. And then if we do that, if we manage to find the oxidation number of S, we can then find the oxidation number of Mn, which is manganese. So let's do it. Let's do it and see what will happen. SO4 2 minus is the one that I've taken from the book. This SO4 will be equal to, SO4 will be equal to minus 2. Then substitution, S plus oxygen is minus 2 times 4. Minus 2 is the oxidation number of oxygen times this 4, equals to minus 2. S minus 2 times 4 is minus 8, equals to minus 2. Then we take minus 8 to the other side. We'll have S equals to plus 6. Our S is plus 6. But the question requires us to find oxidation number of Mn. Let me bring this down here. MnSO4. MnSO4. This MnSO4 will be equals to what? The charge that it is carrying 0 will be equal to 0. Next step is substitution. Mn plus S is 6 plus oxygen minus 2 times 4 equals to 0. Then we solve for Mn. Mn minus 2 times 4 is minus 8. Minus 8 plus 6 is minus 2 equals to 0. We take minus 2 to the other side. We'll get Mn equals to plus 2. This one is the answer for number 6.